Well, good evening, my friends in Ishaka. Say hi, everybody.
Hi.
We're down to 2 students this morning, but that's all good. All right, so we've got a busy day today, so I'm going to just dig right into it. And actually, you know what? I'm going to say a quick prayer, because I never do that, and I always launch right in crazily. So, Father God, Lord Jesus, Holy Spirit, Lord, we are so blessed to know you because you knew us first. And Lord, we love to think about you. And in thinking about you, grow deeper in our love for you and our understanding of you and what you've done and who we are and what you call us to be, Lord. I pray that through just interacting with these big picture ideas that are just clear, concise, reasonable arguments for why you exist at all and why you are somebody who is to be trusted and why we can trust everything to you. Lord, we are grateful. We're so grateful for your word, and we're so grateful for the revelation you've given to us through what you've made and for the tools to explore those. And Lord, I pray for our brothers and sisters in Ishaka, Lord, that you would strengthen them and open their eyes to new ways of thinking about you. And for us here too, that you would open our eyes to new ways of thinking about you. We love you so much. In Jesus' name we pray. Amen. Amen. Okay, so I like to always start off by tackling some questions, either ones that have been raised before or ones that you guys might have. So let me start just by raising one question that occupied most of my Skype time last time with your Ishaka brothers and sisters. And it's basically this, and we face similar types of questions. But the basic question is that how do we know that Christianity isn't just one among many religions that are all kind of aiming at the truth? None of them quite get it right, but we're all kind of going at a single truth. And the specific question that I think it was Dreamer in Ishaka, but I can't quite remember who started it, but they made the observation, and Daniel, I'd be really curious to see whether this is something that your community experiences in Kenya, but made the observation that a lot of Africa looks at Christianity as an import from the West, okay? And they view the approach of Christianity and Christian thought through, the colonizers came and they colonized, and part of that colonization was bringing Christianity and converting us. And if we go back in our history, there's a tremendous amount of native religions that existed way before Christianity came. And so the claim of a lot of those, and this is a big generalization, but some of the African people is, well, our traditional religions are just a different way of expressing this aim towards a single truth. And okay, so you Westerners have your perspective on that, and we have ours, and they're basically heading towards the same thing. And so there's a lot of blending of the old traditions with the new Christian stuff. And so the question that raised was, well, is that true? I mean, and could you apply that to Islam? Just another path up the same mountain, going up the backside instead of the front side. Hinduism, is that just another path? So is it true that we're all scaling up to a single truth, but we're taking different paths to get there? Or are we climbing fundamentally different mountains? And if so, which one is right? And does that mean that the other ones are wrong? So that's a good question. I think we would deal with, maybe not so much in like a traditional religion going to Christianity, but more just in the West, and particularly in America, we pride ourselves in being very pluralistic, accepting, being tolerant of many different ideas. And so the question is, in our pluralism, are we saying they're all basically true, and it just one, you prefer this and I prefer that? Or are we saying, no, there's actually one truth and all this other stuff is wrong? And doesn't that sound really intolerant and like bigoted and hateful? So what do you think about those? What do you think about, how would you deal with that challenge?
Okay, so first of all, I know the issue about Christianity being imported to Africa. Maybe I was brought up in a Christian family and a Christian way, but in school we learned that the way the missionaries came, like Ludwig Craft, and the way they discovered the area, and the way they conquered the area, and all that, and then the way the missionaries came. And so it's brought in a way that that's how Christianity got into Africa and different parts of different parts of Africa. But because of how I was brought, I just came to know that Christianity is the way, and definitely there are other religions and there are other traditional ones that people believe in, but I don't necessarily believe most of them. They are not as popular as the major Christianity. But I know in different perspectives is that the Christianity and the way they receive the gospel also affects, like, is applied differently with different cultures. So maybe culture thing might really change it a little bit, but I think to me Christianity is still the same Christianity that is everywhere. And about the religions, I believe we are serving a God that we believe is a true God. And the way, the little I know, I think the God that we are serving and the God that the Muslims are trying to worship I think is the same one. But I think the issue that makes Islam maybe different from us is that they don't believe in Jesus. Instead, they bring like these other things like Muhammad and the different prophets and do away with Jesus. I don't know if it's because of how Jesus was brought, or the lineage of Jesus through Isaac and all that, and the way theirs came from Ishmael and all that. But I don't think there is a difference between the God that we serve, but it's the difference comes between here. Who's the connector between us and God, especially with Islam. But other religions that worship other things is what I don't believe that we're worshipping the same God. If you're worshipping idols, like maybe the way we believe Hindu people worship, like things like calves or something, things that are man-made,
right,
then I don't agree with that. So I think those are just
okay.
Yes.
Okay. What about you, Caleb? What do you think?
I agree with Daniel. I think the connection with God is huge. Because, I mean, looking historically, before I came to this class, I didn't realize that there were so many documents and stuff, like validating everything that we read in the Bible. That was
Mhm.
huge for me because
Mhm.
how can I take what is I'm reading
Right.
as true?
Mm-hmm.
The one thing I've noticed, and I don't know much about any other religions, just the
Mhm.
general stereotypes,
Mhm.
but what the Christian God is a God who is good and all loving, and his goal is for us to choose him, and so we can be with him. And I think as opposed to other religions, they don't really have any means for that because we're given the gift of grace
Mm-hmm.
through the blood of Christ.
Mm-hmm.
And I think whereas other gods in religions, it's conditional.
Mm-hmm.
And I think part of that is weighing what feels true in my heart. And yeah, that's kind of my point.
Mm-hmm. Mm-hmm. So, yeah, I think you guys are spot on. With regards to the question about are all religions basically the same, heading towards a common peak, or are they basically different? And I think that a very naive look, a very uninformed look at religions could say, well, they're all basically the same because all religions have an idea of the supernatural versus the lack of the supernatural. So if you just say, well, we can clump together all religions because they all involve the supernatural, and I'm not a religious person, so I don't believe in the supernatural, and that's the big divide. So, okay, in that respect, that's a very surface level view. Okay, they're all supernatural. Okay, great. Well, that's what religion is all about. But that doesn't really tell us much. Now, as soon as we look into the different examples of major world religions, then we can ask the question, well, are those basically the same, or are there fundamental differences? And that's where an understanding of the core beliefs of the different religions, including our own, can reveal that the truth of the matter is they're all radically different from each other once you get into any kind of important questions about what they believe and why they believe it. For example, you could think even that in Islam, right? It's like, well, they've got Allah, we've got Yahweh, and they came from Judaism. They came from they have they revere a lot of the same prophets that Judaism does, but they disagree with the Christian when it comes to Christ. And so they claim that, well, Christianity is a corruption, the gospel, the good news, has been corrupted, and what Christians believe now is totally not the truth. And in fact, the core central belief of Christianity, which is that Christ is divine, the Son of Man, God in the flesh, came, took on our sin, died on the cross, and by doing so paid for our sin by grace. We've been saved, and through faith, believing in that, that's how we enter into, that's how Jesus is that in between, right? He's in between because he's the high priest that shed his own blood and atoned for our sin in our place. And Islam would fundamentally deny that, right? No, Christ is not divine, because associating anything with Allah is the worst sin you could do. It's like we are monotheistic, monism it's called. It's like one being, one person. Can't be multiple persons. Okay? Whereas Christianity, it's one being, yes, monotheism, but triune in nature. three persons. God can be three persons at the same time. And in Islam, how do you get to heaven? Well, you have to do all the Islam things. You know, you have to say the Shahad, you have to pronounce it, you have to pay your tithes, you have to go on, have to go to Mecca, you have to do this, you have to do that. And then, if Allah wills it, then He'll let you into heaven. Okay? Or you can be a jihadist and die in service to Allah, and then you go straight to heaven, and you get 72 virgins or something like that. Okay? So even closely related, springing from the same basic root, we have these fundamental differences that are diametrically contradictory. And if you just go through all of the major world religions, what you find is that they may all be false, but they sure can't all be true, because if they were all true, they'd be a mass of contradictions. And it's not just kind of different ways to get to the peak. It's like their idea of the peak, their idea of salvation. What is the end goal of all this are fundamentally different. So not only are they climbing up a different way, but they're climbing up a different mountain. So our goal as apologists is to build a good reason for why, out of all the religions, we believe that not only are they false, but that Christianity is true. So that's our overarching goal. So let me change subjects a little bit. If you were able to watch on YouTube The Privileged Planet, or in your reading about the fine-tuning related to the cosmological aspect, that is looking out in the telescope, any comments, questions? Did you learn anything? What do you think?
I enjoyed it quite a bit. I watched it in 15-minute chunks throughout the week,
Mm-hmm.
And it broke it down pretty easily.
Mm-hmm.
Like, if there was things that I couldn't quite grasp in the book, I'm like, oh,
Mm-hmm.
it's right there. And then
Mm-hmm.
at the end of it, they had that half hour with the different interviews. Like
Yeah.
William Craig was
Right.
one of them. So overall, I thought it really nailed the point home.
How would you, you're having coffee with somebody and say, hey, I watched this amazing video that just is all about design in the universe and how amazingly fine-tuned the universe is. How would you describe that idea of fine-tuning? It's a good way to, what do you think now that you've been exposed? How would you explain that?
Well, I went to church on Sunday, and I was just striking up a conversation with my sister.
Mm-hmm.
I was telling her, I was like, you ever think about gravity, how that works? You ever think about this and that? I was trying to tell her, isn't it, I was kind of bringing in like the beginning of the universe too. I was kind of telling her the basic arguments, but I was telling her that, those constants in the universe, had they not been exactly where they are, where us talking right now wouldn't be happening, because nothing would work.
Right.
And I got her to start thinking about it. I think I got her to start watching the video.
Yeah.
on
Good.
that too.
Excellent. Well, what's amazing is that, and this is a trend that I think you can confidently say, and that is and you'll see this, we've seen it with looking through the telescope. We're going to see it even more looking through the microscope. But the more people learn about how the universe works and how life works, our understanding is growing by leaps and bounds. Our understanding, our knowledge of the universe, our knowledge of life is growing like you wouldn't believe. And thank God for the technology that allows us to see this. But with that growth is a deepening awareness of the design that's present, that gets revealed when we explore those. So like you think, well, who cares if the gravitational constant was a little bit different? Well, that's a good question. Does it really matter? Well, let's try twiddling it with it. And now that we understand, in pretty dang good detail how gravity works and how that affects the operation of the universe, we can go in and say, well, let's assume we tweaked it a little bit this way or tweaked it a little bit that way. What would happen? And you see that it's like this house of cards or stacked, whatever analogy you use. Sometimes they use, pencils stacked one on top of each other. So you take the gravitational thing and you go tweak a little bit, and the whole thing just falls down because it has these ripple effects. And then you realize that every one of these variables, every one of these constants, every one of these initial conditions, based not on our ignorance but based on our understanding, is becoming clearer and clearer. Man, it's got to be dead on within like this narrow range. And so, and not only that, and so we're appreciating more the degree to which these things have to be fine-tuned. Like, it's got to be pretty dang close, otherwise bad things happen. And then we're understanding too, on top of that, that hey, it's not just the gravitational constant, it's not just the strong weak nuclear force, it's not just like the speed of light, it's wow, everything, as we develop and refine our laws of physics and our understanding of how these things, we're finding more and more things that we never even thought about that have to be just right. Otherwise, something screws up. So that's fine tuning. It's like, wow, we understand this and we're astounded by how dead on it has to be. And this principle is well recognized by scientists and confounds them to a large degree and motivates trying to find answers that maybe don't involve a designer or a fine-tuner. How do we explain all this stuff without a fine-tuner? And you can find, books, written by and quotes from very, leading figures in these disciplines that are trying to solve that problem. And by trying to solve that problem, they're acknowledging that the problem exists. It's no controversy, except a few fringe people. There's no controversy about the challenge of fine-tuning. It's how do we solve it? And a lot of people have faith that eventually, with greater understanding, will eventually figure it out like, oh, I see, it had to be that way or whatever. But the track record has been consistently that the more we understand, the greater understanding, it makes the problem worse. And by making the problem worse, it makes the case for a creator all the more strong, because that really answers the question. And all it requires is that you've got to be open-minded to the fact that there might be an all-powerful mind beyond the cosmos that's responsible for this. And the more evidence from more different angles that we bring that are all speaking to that, that being out there that we call God, the stronger our case becomes. Okay, so last question here. I just want to remind you, answer me this. What remarkable other quality does the fine-tuning features for life permit? So it's not only that we find that in order for life to exist, the universe has to be fine-tuned. But what's another thing that is kind of like a bonus for all of that fine-tuning for life?
That's a tricky one, because in order for everything else to exist, there has to be life. So maybe the quality of the other quality that the fine-tuned features for life for me would be like, I think it's something that we can be amazed by how God
Yeah.
did the things
Yeah.
and created those things.
Uh-huh.
Because if it's taking all these people who are trying to find evidence,
Uh-huh.
all this effort they're
Right.
trying to dig inside, it helps us think about how God is like supernatural.
Yeah.
How like where did God learn what
Mhm.
they're doing? He didn't have all these
Mhm.
gadgets like machines and all
Mhm.
that. So
Mhm.
it means that God is wondrous and
Mhm.
marvelous in the
Mhm.
things He does.
Right.
Because up to now they don't have any answer of how that could have happened. Like being like for fine-tuning to be exact the way it is, it's just an amazing thing.
Mhm.
It's just a miracle. It's
Right.
just a miracle, nothing.
So when
If
go
so,
ahead.
kind of what you're saying, not only is it fine-tuned for life, but we have the ability to notice that, so we can look out in the cosmos and say, hey, what's going on? Because I think it was in that video they talked about how if it was off a little bit, our atmosphere would be like, you wouldn't be able to see it all. You wouldn't be able to see anything.
So,
in the
and
stars.
what
You
would
wouldn't
that-
know
And what would that mean?
there's more out there.
That's right.
So not only are we
So what-
fine-tuned to live, but we are fine-tuned to discover.
Precisely. Exactly. And isn't that a little jaw-dropping? I mean, it's like, for me, it's like this little bonus that it's like, okay, just like you're saying, the fine-tuning things are motivate us to discover about God, right? It's like you see all this fine-tuning stuff and we discover God. Well, the very things that are fine-tuned for life coincidentally happen to be the very same things that are required for any intelligent life that could be there to actually discover stuff. And that to me is like, wow, you really got to be an amazing designer to weave those two requirements together so that not only it's the things that allow life, but it actually is exactly the same things that allow that life to discover stuff about
Well,
reality.
it's like, it kind of reminds me that if there was no other way for you to hear the gospel, in Romans, Paul talks about general revelation.
Uh-huh.
It's like, that's our gift from God, that we
Mhm.
have that ability
Mm-hmm.
to know that He's out there,
Mhm.
and there's something more to it.
Yep. Yep.
So if scientists are trying to find out about how old this, it means God is the greatest scientist.
That's right.
So, because
Yep. He is the greatest scientist.
I've not even gotten to a
That's-
small bit of what God
That's
has
right.
done.
That's right. Well, and you know what? What you're talking about is actually, God has gifted each one of us with different abilities and giftings and passions and understanding, and so there's a community of and I count myself kind of in this group of engineer, computer scientists, technologists, chemists, biologists, who who see God as this amazing engineer. Like, wow, look at what he did. And in fact, here's something you might not have known, but there's a whole discipline of science that is growing by leaps and bounds right now, and it's called biomimicry. Okay, and what it is it's the science of looking at solutions to problems that have evolved, that are present in nature, and to try and then learn from that to say, how can we take this amazing design that seems to perform this function in nature, and how can we understand and then take that and apply it to, you know, our design. Like a crude example would be like, you know, how can we study the flight of birds to better understand how to fly, you know, mechanically? And especially in like medicine and stuff, we kind of do a lot of that, and it's been historically really trial and error. Like, let's try all these different chemicals and drugs and see which one works. Well, there's a lot of opportunity to see how immune systems in nature work, and then say, now that we understand what's going on, to make, you know, for the immune system to be able to combat various issues, now we have a much better understanding of how to tackle the issue from looking at what the design in nature is. I remember one, I don't know if this will resonate, but it really resonated with me, and that is that when you're designing like any kind of optics, that is lens systems, like for a camera or for a telescope or a microscope or anything, and even the design of displays that we use, there's optics in the displays that we use. There are, you know, there are the surfaces of the lenses. There's the surfaces of like the films that go on your display, and each one of those surfaces is an opportunity to reflect light. Okay, so if you look at the window, you know, one of the things about a window that you know it's there is like, oh, I can see reflections of other things, and that's just a little bit of the light coming back. Well, for a lot of optical things, especially when you have a whole bunch of lenses that are all stacked, say in a fancy camera lens, those reflections add up and they start obscuring the image, and they just degrade the overall performance of the lens. And so people have come up with ways to reduce the amount of light that gets reflected off a surface, like off the surface of a lens or off the surface of a window. In fact, all of these windows are coated so that they reflect, they're designed to reflect more of the infrared light and not reflect more of the visible lights, because you want the visible light coming through and the heat bouncing off, because you don't want to heat your building from the sun, because then you got to pay for air conditioning. You also don't want the heat that your heating system is doing here to go out the window. You want it to reflect back. So people have designed like coatings that you put on optical surfaces to change the reflection behavior. Well, it turns out that there's a structure in the eye of a moth that is like by far and away the best anti-reflection coating in existence, like 100 times better than anything man has ever designed. And people have always wondered, and it's like, wow, this moth eye is like, it's perfect. There's no reflections coming off it. How does this work? And so they go in, they learn that the structure of a moth eye, the surface of a moth eye is, number one, it's a completely different approach than what we do with our optics. Completely different approach. And it involves these amazing like nanostructures. So they're molecular structures that are just right so that it turns out that they'll let light through, but they won't let it bounce back. And it's just the physics of how these structures work. And if you look at them like on an electron microscope, they just look like the weirdest things. They look like a bunch of like little cones like sticking up, like I don't know how you describe it, but like, yeah, just a bunch of cones. And so people have learned from that design and been able to reconstruct and build, they're called moth eye anti-reflection surface coatings. And it's really weird, and I can speak to this with experience because the way people demonstrate it is you get a piece of glass. It's a regular piece of glass, and usually you hold it up and it's like, it looks transparent. You go, oh yeah, it's see-through. And then in the center of it, they'll put this moth eye coating on it. And when you see that, and then you hold it up, it's like you could swear that where the moth eye is, there's a hole there. There's like, normally you can hold up a piece of glass and if you touch it, you can see it because you can see reflections. This, you cannot see a reflection, and you're looking at it and you go, I know I could stick my finger there, but it's there. And especially in contrast to the area around the glass where you can't see, it shows up really weird. So all of that's to say that that this design that we find in life is not only awe-inspiring, but it's also useful because we can learn from it. But when you have a better appreciation for what's going on and how that is, if you're a scientist, if you're a computer programmer, if you're an engineer, you'll look at these things and go, that is some amazing code. That is amazing. Yeah, I could go on, but I'll give you just one more example, just because it just floors me. But as we're going to learn in today's lesson, a huge part of evidence for design is in the basically software programming that you find in life in the DNA. And as you know, with any kind of software, when you make copies of that software, which is like life reproducing, when you stick a hard drive in or you upload something, if you're a software engineer, you realize how much is going on to make that actually happen and how prone to errors there are in getting it from your hard drive out to your USB stick or up to the internet. And there's all kinds of built-in error correction that's programmed in. So the software guys have to write all of this error correction in order to compensate for the errors that happen. Same thing happens in life. So turns out that in the DNA structure, in the information there, in the software there, there's layer upon layer of amazing error correction that people have been able to observe and then learn from and marvel at, because it's not just functional. It doesn't just do the job. It does that job better than anything else we've ever done. And so we look at it and go, wow, how does that bacteria have error correction code in its DNA when it reproduces to really mitigate against mutations as it reproduces? Wow, that's amazing. And it's doing it like better than we ever can. So that's my soapbox. So good place to transition and go into the second part of the teleological argument. This part is not really covered by William Lane Craig, and so far he hasn't applied his time and talents to addressing, at least publicly, the question of evolution, which is the question of design in life. So he says, as far as a tactic for him, he says, you can easily establish the requirements for a designer from the design in the cosmos. The fine-tuning of the universe to support life is compelling, persuasive, effective in arguing for a designer, in arguing for God. He says, this is William Lane Craig saying, I don't need to go to the much more emotionally laden issue of evolution in order to present a design argument from that aspect. So, so that's his tactic. It's not covered really in the book. I believe that it's an area that is, it is more challenging because it's a more complicated topic, and it's more open to pushback, or I should say, a lot of back and forth. Well, you think that, this is improbable. Well, I think it is improbable. Well, how do you know? Well, the numbers you crunch and they're big. Well, my numbers are small. Blah, 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 back and forth. And like, in order to really answer the questions, it's more difficult to like get to okay, we know this. But then again, overall, I like it because it's so intuitive. And once you grasp a few of the concepts, it's like it's another great tool in our toolbox to bring out. So I'm going to cover it. So just to back up a little bit, we're still here now, 7 weeks into it. We're still building our case just for the existence of God. And again, we're thinking, well, when are we going to get to Jesus, right? And we'll get there. But for Jesus to be who he says he is, we need good reasons for why God exists at all, because Jesus' claim is, I'm the Son of God. And so if I'm the Son of God and I'm the creator of the universe, there has to be a God in the first place. That's the purpose. Again, it's like building a foundation. We want to get our foundation nice, strong, steady, level, and good, because everything else is going to rest on that. We don't want to have a shaky foundation, so we build a bunch of stuff, and then somebody comes and just undercuts us because we haven't built that foundation. So we've done the two cosmological arguments that are just really big picture. How do we explain that anything exists, and how do we explain that something came into existence? And then we did the argument from design, teleological argument, and last week we covered the argument from the design in the universe. So this, and then the last one that we're going to do, which is next week, so you'll be reading chapter 6, which covers this, is the moral argument. How do we explain the existence? What is the source of existence of objective morals? But before we get to that, our argument from design, the teleological argument, the telos, the end goal, the finish, the home plate, that's where teleology comes from, is design. So we've taken two approaches. One is for the design of the universe for life, and that's looking out into the heavens through our telescopes, and now we're going to look through our microscopes at life itself, and that's through biology. So here's the basic structure, and it's similar to fine-tuning, but it's more, I would say, more like design in the sense that it's put together for a purpose. So what we have learned as we look at life, and this is very intuitive whenever you look at life, it just leaps out at you saying, wow, that's pretty amazing that it works. But the way the things that life encompasses are chemistry, there's mechanics going on, there are structures, assemblies within life, and then there's the behavior of life itself, all of which exhibit features of design and purpose. Okay? And so this is not only intuitive, but it's something that we discover as we learn more about life, as we look in the microscope. So the question that raises is, what's the best explanation for that appearance of design, for these features that look like somebody put them together, and they put them together for a specific purpose, that is, so this thing could live. And a good analogy that has been made and has become kind of the classic example is it's the watchmaker argument that was developed by a guy named William Paley in the 17th century, I think. And he basically says, hey, if you're like walking in the woods and you stumble upon a watch, at his time it was, you know, a cool fancy pocket watch, because that's what they like. If you stumble across a watch, your first reaction would not be to say, wow, I wonder how like this randomly just, you know, was created by, you know, wind and metal and rain. And you wouldn't say, huh, it's amazing that natural processes resulted in this watch, because I look at the watch and it's made up of all these intricate gears, and it seems to be performing a specific function to tell time. And so you would say, I wonder who designed this watch. Where did this watch come from? You wouldn't say, how did this come about by natural processes? And he said, by the same reasoning, when we look at life, it looks just like a watch. I mean, even more so. There's all these features, and they seem to be designed for a purpose, and there's all these machinery. And he had no clue how vast of an understatement it was for him to compare it against a watch. Because compared to a watch, life is like infinitely more complex. But nonetheless, his argument holds. He said, no, you would naturally, you know, be searching for the designer of that watch, not for what were the natural forces that made that watch come together. So the same thing can be asked about life. So the question is, when we see life, is that the product of a natural process or processes, or is this the product of a designer who intently put them together in a specific way for a specific purpose to live and eventually to be intelligent and to be able to relate to the designer? So that's really the question that is being addressed in considering teleological things. So let me give a couple examples of those features, like when you look at the watch and you see gears and you know, beautiful decorations and a lid and a winder and hands and all that stuff. Let me give you some examples that are common to all life, and particularly in the simplest life, that exhibit these features of design. So first and foremost, there is this thing called DNA, and DNA is basically a chemical. It's a string of chemicals whose order. Here's a quick overview of DNA. DNA is basically a chemical molecule that has 4 different types of main components. Think of those as letters. And it's just a long string, you know, like hundreds, thousands, millions of these letters, all strung together, that encode the information needed for life. It's the information needed to do all the life things, to build life, to reproduce life. It's like the software. The DNA is like your hard drive, but what's in the DNA is information that is essentially the instruction set. It's the recipe for life, put it very simply. And so DNA itself and how it gets used in life, and I'm talking the simplest forms of life. I'm not talking about you and me and how our brains work. I'm talking about you get down to bacteria, you know, single-celled organisms. The smallest, simplest forms of life have this DNA in it, which is essentially an information processing and storage system. Okay, it's basically embedded software. Okay, so that's one example. Within the simplest life are energy processing systems that are capable of converting chemical, heat, light, energy into useful work. In order for a thing to be living, it's got to do stuff. In order to do stuff, it consumes energy. And so there's entire systems within the simplest life that take in various forms of energy and turn those into useful work. That could be making more of itself. It could be, taking in chemicals that are the building blocks for things it needs to keep running. All number of things. So energy processing system. Information, energy processing. We find in the simplest cells essentially molecular factories that build the pieces that are needed for life systems. And when I say factories, I almost mean that literally. I mean, these are like, there's a lot of analogy in terms of how life works inside the simplest form in doing all these information processing, in doing the energy processing. In order to do all that, there's these factories that make things and do things that are needed. Included in those factories are these amazing little molecular machines, literally like machines, that do things both inside the cell and also that are useful for the cell outside of itself. And we'll talk about one example of those. The simplest life has the ability to both replicate itself and repair itself. So there's like all these systems. So these are just a few examples when we learn and understand how they work in DNA, in energy processing, in the factories, in these molecular machines. They're all like screaming, just like Paley's watch was, somebody or something had to put this together in an intentional way so that it did the things that it does. And the idea that somehow these amazing design features just came together through natural processes seems intuitively false. And so the history of science since Darwinism has been to try and do that nonetheless. Okay, so let's take a quick break, and then I'll give you some examples of design in more complex life, and then we'll go into evaluating the best way to explain this. Natural processes or a designer. Okay, so take a break. Hi Ishaka, we're back, and we're kind of doing a little side thing on abstract objects because Caleb over there asked a really good question. So stay with me. So we're talking about the doctrine of divine aseity, which is that God alone is the only self-existent necessary being. And the question is, what do we do with all these abstract objects like numbers and laws and mathematics? And so William Lane Craig's The class was all about the different ways people have viewed things like abstract objects in relationship to God. And Craig's position, and he wrote a whole book about it, is that, let's see if I can, is basically that these abstract objects like numbers are convenient fictions. They don't really have any existence by themselves. And so there's an idea that is called conceptualism, which says that those ideas are rooted in the mind of God. And I came away with the understanding that Craig actually goes one step further, saying, yes, God entertains these thoughts of like numbers, but the numbers themselves are really just useful fictions. They're useful for describing other things, other thoughts, contingent things, but they don't have any existence in and of themselves. So anyway, that was the topic of the class. And you know, you get your taste of William Lane Craig, and people like, it's not unique to him. He's a great thinker and everything, but you get your taste of them through like the books they write and the debates and then you take like a graduate level class from them, and you're like, I don't know what this guy is talking about. I mean, what seems so clear, because he's using language and philosophy, and he uses like people's names, like, oh yeah, Hume said this and Kant said that, and Wittgenstein said this, and the expectation is just by the mention of the name, you understand, oh, okay, that's this whole thing of thought. And then this name means this whole, and if you're not like a student of all that, holding it all together was quite challenging. Yeah. But it was fun nonetheless. I was just, it was another experience of just like, wow, like men are actually pretty stupid. And we're pretty foolish relative to God. But relative to like our own comprehension, it's like, wow, people can really be smart. I mean, I cannot believe the bizarre things that these people think of. And you get the same thing with cosmologists who are trying to come up with all these different cosmological models to explain the beginning of the universe and gravity and time. Oh man. Okay, so another diversion. Sorry, I have the freedom to do this. So you take somebody like William Lane Craig, and his career has been one of tackling a subject for like 10 years and wrestling it to the ground for 10 years. In the process, writing a book about it, and boom, there you've got. And then he's like, okay, I'm done with that. Cha-ching, now I'm going to move on to the next 10-year project. And he spends 10 years on it. One of his 10-year projects was on the subject of time. Okay, how do we understand time? And how do we understand God's relationship to time? And this is all useful stuff. I mean, it's like, well, who cares? Or, does it really? Well, it's really working in the deep, dark trenches of philosophy, theology, and apologetics, ultimately, to be able to, answer the ever, like, deepening, probing questions that, some of these questions just start, bringing up questions about time. I mean, did time begin to exist? And how do we even talk about like, well, what was before time? Well, there wasn't time to be before, but what was it like then? And our brains just can't think of like an existence without time. So is there such thing as like timelessness? Or and what is time? Is something separate from God? Or does God experience time? Or did he create time? And if he created time, well, what was he doing before he created time? And what do we even mean by that? So anyway, that can be 10 years worth of work. And he wrote a book on that. And I will tell you, his book, Time and Eternity, is probably the most difficult book I've ever read, trying to understand it. It was really, really hard. So, okay, rewind. So, I talked about some examples of design in simple life, and now there's clearly lots of examples of design in more complex life, such as us, such as Fido, your dog, or even anything. Even, I mean, life, complex life, you know, as soon as you move beyond like single cell stuff, which is called simple, even though it's not, and you get into multicellular life, or even some more advanced forms of single cell life, it rapidly becomes very complex. But examples are things like vision in our image processing system, other sensory input, taste, smell, hearing. How do we interpret sound waves and turn them into language? Our immune system, the motor control systems that allow for amazing mobility, adaptation to a wide variety of environmental conditions. So, you know, take human beings, we can live in cold, we can live in hot. How do we, you know, we sweat, we control our body temperature. All that is just amazing design. Sexual reproduction, thermal regulatory systems, intelligence, mind, reasoning, self-awareness. So, you know, just to try and think about it, just the vision system alone of, say, mammals is an amazing process that involves very complicated optical systems, sensory systems, light control of those. Light has to come in to your eye. The photons have to hit your retina. Your retina has to be such that, depending on the flavor of light, depending on the spectra, is it red, is it blue, is it green, all these things, it triggers electrical impulses that are then carried by your optic nerve into your brain, which takes all this data. And essentially, what's happening in your brain, when you see something, you're not like, you know, your eyes aren't going out there and touching and feeling, right? What's really happening is, you know, photons are coming at you and entering into your eyes, and those are going into your brain, and your brain is inside your brain constructing a representative picture, image, three-dimensional image of what's out there. So, and then you're perceiving that model that your brain has put together. So you're not really like seeing out there, you're perceiving a model that your brain, your mind has constructed based on the data that it's inputted, and that we experience as like sight. And every step of the way in that is riddled with very complicated design work. For a while when I worked at Microsoft, I was working on 3D cameras. And 3D cameras are cameras that not only take a snapshot of like a painter, like that would see a two-dimensional thing. It captures that, but it also captures data about how far away everything is. And from that depth map, you can build a three-dimensional view that's much more than just like what your normal camera does, which is just a flat two-dimensional view. And so the software, the image processing system, to both collect that data and then turn that data into a meaningful model that kind of reproduces what is actually out there, three-dimensional. It's like, wow, unbelievable. So our minds, our brains is doing that, and it's doing that very rapidly, right? So I move my head and it's like, whoa, another view, whoa, another view, boom, instantaneous. Just phenomenally amazing. So then, again, the question and the challenge is, how do we explain that? how do we explain the vision system? Okay, so can these things that we observe and that we intuitively say, that looks like a watch to me, that looks like a camera to me, that looks like a computer to me, that looks like a robot to me, all of these things that seem to be have design with a purpose. They have all these things because they have a purpose. Like, why do we have eyes? Well, so we can see. Why do we want to see? Well, so we can, interact with the world. We can catch food. We can do all sorts of stuff. So, so the question is, okay, despite the challenge there, is there conceivably a way that natural processes could explain this? And up until 150 years ago, a guy named Darwin showed up, and you guys have heard his name. Nobody had really a very good explanation for how this could be. So Darwin came up with one possible explanation, and he called it the theory of evolution. And he wrote a book about it called The Origin of Species. And so that theory is a theory that attempts to explain why we see design in life. And it's a natural process, and it's pretty easy to understand. So let me walk you through, and I know you've probably heard it, this is maybe review, but it's helpful to kind of take a 101, Darwin 101 approach, and remember the basics of how this works. And again, this is 150 years ago, and it's still with us today. So it's the reigning explanation with a lot more detail behind it. And it's kind of the, to some extent, it's the dogma of culture and science, the scientific community today. So here's the basic idea. So you got life, it reproduces, cells split, they form new cells. Insects make more insects, et cetera, et cetera. But every time they make a copy, every time they reproduce, just in the process of reproducing, there's always a few variations that happen. So maybe, my children are a little bit taller than me. Maybe their children are a little bit fatter than me. Maybe their children's skin is a little bit different color. There's all these slight variations that occur in the process of reproduction. And even at the cellular level, when cells reproduce, there's always slight variations. So, so these variations oftentimes can either help the thing survive, or they can hurt the survivability of the offspring. And so the really basic idea is that, well, of course, if you have a variation that means you're better able to survive, you're probably going to survive. And if you survive, you have a better chance of reproducing. And if you reproduce that change, then it will be carried on. So good changes survive, they get passed on, and bad changes get weeded out. Because if it's a bad change and you die, well, you're not going to be able to reproduce to pass that bad change on. Now, most of the time, the variations don't do anything, right? So you just keep going and you don't notice any change. They might build up after a while, but the ones that do help get preserved, the ones that don't help get discarded, and that's what's called natural selection. So you've probably heard natural selection or survival of the fittest. Okay, so you get a variation, makes your survivability better, you survive. Now what Darwin said is that, okay, well, if we let this play out for a while over multiple generations, then what are just very slight variations, like my son is a bit taller than me and his son will be a bit fatter than me, and etc. Eventually, those slight variations add up to pretty major changes. And he said, you know, we see this in domesticated animals. Look what we've done to wolves. You know, we took wolves as pets, and from just wolves, we've created these whole breeds of dogs, anywhere from these tiny little Pikachus or whatever to these huge Great Danes. And all of that is just people doing the selecting, saying, I want a small dog, so I'm going to take 2 small dogs, and their offspring are going to be a small dog. I'm going to take, and I'm going to take the smallest one there, and I'm going to keep picking the smallest one, and pretty soon I've gone from a wolf to a kind of small, cute little Chihuahua. So, so that's like human selection, and he used examples like livestock and stuff like that. People breed things for certain things. He recognized that that could happen, but he also said, well, even without people picking it, nature itself is going to select the ones that survive better. So natural selection. The selection is being done by nature. So if you start taking these slight variations, adding up to major changes, and then major changes, maybe over time they could add up to, wow, all the variation we see. Okay, that seems like, you know, if that process really worked, then maybe it's plausible. And you could imagine starting with like the simplest form of life. Let's just say, you know, a blob of protoplasm, whatever pre-life is. Once it gets started, you know, if it's like this small self-replicating thing, eventually by this process of random mutation and natural selection, it's going to get better and better survivability, and different environmental forces are going to push it towards different forms, and you know, different geographies are going to make it adapt and evolve, and it all adds up after, you know, however many millions of years to be able to explain all of the life that we see. So that's basically Darwin's theory of random mutation and natural selection. So from Darwin's time to the present time, and actually people started understanding this 50 years ago pretty well, started confirming the basic idea behind this and adding meat, adding detail where Darwin didn't have any visibility. So Darwin had no idea really how or why these variations happened, and he didn't know how they got passed on. But with the discovery of DNA and our much better understanding of how life works, what neo-Darwinism is, and I throw that term out because you'll encounter it, people will speak about neo-Darwinism, is just adding details to Darwin's theory. It's kind of like moving from Isaac Newton's theory to Einstein's theory. Same basic idea, more detail. So the detail that neo-Darwinism brings to it is that the random mutations, the variations, come from mutations, changes in DNA. So the DNA holds the instructions. Occasionally the instructions get jumbled up, and most of the time those jumbled up instructions are bad, and the organism that inherited them dies, so it doesn't continue it on. But sometimes, very occasionally, those random instructions actually benefit the survivability, and that gets passed on, and if it survives better, then that will get passed on, and so on and so on. And they all build up to this amazing diversity of life, and it's really that natural process of random mutation, working on the DNA, natural selection, picking the changes that benefit survivability, that can explain all of the life that we see today. Okay, so so that's the basic idea. Let me back up a little bit and say, one possible really easy, so this is the challenge to say, well, yeah, it looks like life shows signs of design, which would imply a designer. And you're right, in some ways, life does show signs of design, but really we can explain that by a natural process called Darwinian evolution, called neo-Darwinian evolution. So the question for the Christian, the question for somebody who believes in God is, well, how do we revive this argument? You know, is really life just the product of natural processes? And if it's just the product of natural processes, then what need is there of God in that process? So is there any overriding purpose other than just survivability inherent in life? And really where it hits home is for us human beings. Did we just evolve? And how does this match to Scripture, et cetera, et cetera? So it is a big challenge for us to deal with. So one way to deal with it, and Christians have dealt with it fairly effectively, at least in principle, is to say that you know, the Earth has only been in existence for, say, 6,000 or 10,000 years, because that's what Genesis says, and you know, there's no time for this natural process to occur. You need millions of years in order for this to happen. So if you're a young Earth creationist, which I'm not, but if you are, that's your answer. There wasn't enough time for these processes to happen. But on the other hand, if you look at the evidence from multiple points, and if you look at Scripture carefully and you say, well, actually, it does seem like the universe and the Earth is much older than 6,000 years. So does conceding that, or does acknowledging that truth, then open the door for this process? And the answer, the short answer is no, but let me explain that. So again, I'm going to take the position of, if you're a young Earth creationist, then you got your answer. There you go. Boom. 6,000 years, you don't have enough time. End of story. The process could never take place. The old Earth answer is that even assuming we've got enough time, there still are fundamental questions. So questions involve this. Number one, you've got to have the origin of the first life. So this whole process, this whole natural process, assumes right off the get-go it works when you already have something that is replicating, that it's passing its information on, it's making copies of itself, and that thing is has got the things that get varied, that get mutated. And so you kind of need, it's kind of a chicken and egg kind of problem. It's like you really need that egg first before you can start hatching chickens that can have more eggs. So you've got to start somewhere. And Darwinian evolution doesn't try to answer that question. But it's a question that needs to be answered. It's like, well, how do you even get started if you don't have the first life? So if you can't really explain life itself with Darwinism. You can only explain, maybe, well, give me the first life and I can show you how I can get all the diversity of life. So that's one problem. How did life come from non-life? That process is called abiogenesis. So the discipline of studying the origin of the first life is called abiogenesis. And there is a theory, big picture, called chemical evolution. Okay, it's not Darwinian evolution, but it's a similar kind of thing where it says that chemistry, there's ways in which chemistry can be not living, but it can be self-replicating, and somehow we can go from a chemical evolution thing to a biological evolution. In that gap, there's really no explanation to date. But anyway, that's how science deals with the two main questions. What's the origin of life? What's the speciation? What's the history of life? So that's the first question, is origin of life. Second question is, can this process that involves random mutations, and by random it means like, you know, there's nobody choosing for some particular purpose, like, ooh, if I do this, it'll survive better. If I tweak this, it'll survive better. It's just happening randomly. But the result of those random processes is that the instruction set, the recipe, the software, the embedded code, gets better and better and better and better. It gets more sophisticated, more complex. So is it really plausible that just by randomly messing with stuff, that in this process of natural selection, can things really get better? It's kind of like asking, you know, say you download a new app, and anymore, you know, it's like, it's hard to relate this, but it's really analogous to software. So software is basically, let's think of, are you a Windows machine?
Mm-hmm.
Okay, you got Windows. I don't know where we're at. Windows 10, Windows 11?
I think Windows 10, yeah.
Windows 10. Okay, Windows 10. Okay, the entire Microsoft team of however many, 20,000 engineers, really dedicated towards writing the code. And that when all is said and done, it's a bunch of ones and zeros, okay, that go into that machine. And when you give that machine a bunch of ones and zeros, it does all those amazing things, okay? So now, have you ever had the experience where, you know, it's like your computer like hangs, or you got to hit reset or whatever? Well, that's when things skip a gear. And in the operating system, now these are very sophisticated things, so they have a bunch of error correction. But if you start going in there and like randomly just like changing like some of the software code, I mean, like, imagine changing one thing where it says, if A equals B, to if A doesn't equal B. Boom, that can kill your whole machine. Boom, right there. It will blue screen of death. And it stops working. And so it doesn't take much, to be honest, of screwing up, of mutating your code before your Windows operating system no longer works. It dies. By the same token, kind of flipped around the other way, that Windows operating system is one heck of a instruction set. You know, people spent 50 years. I mean, I don't know how long Microsoft's been around, but, you know, just the evolution of Windows has been a process of, you know, tens of thousands of engineers working years and years to develop this very complicated instruction set. And it's not unreasonable at all to compare the operating system for your PC with the operating system for a simple cell. If you look at what a simple cell has to do, in some ways it can do more than your PC. It's just amazing. So the instructions behind that are every bit as complicated as the instructions behind Windows. So can we really attribute this random mutation of chemical letters in the DNA to explain that? Does the fossil record support this theory? In other words, when we look at the history of life, Darwinism says takes a long time, and it's slow, gradual variations that add up to a whole bunch of stuff. So when we look at the history of life through the fossil record, does it jive with the theory? Does it make sense? That's a question. And lastly, there are some structures in life that are called irreducibly complex, and I'll explain what that means in a minute. But can this process explain those type of structures. So, so let's look at those, and I'll probably have to go quickly here. So on the origin of life, there is, the fact of the matter is that there's no consensus on a natural process to explain how life came from non-life. People have been working on this for seriously, in a modern laboratory sense, easily 50 years. Okay, trying to explain how life could come from non-life, and we're further behind in that than we've ever been, despite those 50 years. And the reason we're further behind on that is because, unlike in Darwin's time, people had no idea how life actually worked at a chemical level. They had no visibility to what was going on. So it's kind of easy for Darwin to think, well, you kind of got this blob of jelly, like this goo that you see in a pond. And maybe that's the first life. It's really, really simple. And so that could just kind of come together naturally. And, you know, and yeah, maybe it's improbable, but it's definitely possible because it's pretty straightforward. Well, the challenge is, the more we learn, and up to today we learn it even more so, is that even the simplest life is really complicated. So getting from a glob of chemicals to this highly organized form of the simplest life is a huge gap. It's not that little, start with a little blob of protoplasm in a pond and then, you know, add a little spark and boom, you got the first simple life. No, it's a way huger leap than that. And we know this not from ignorance like Darwin didn't know. And so you can give Darwin a little bit of grace because he just didn't know. He was guessing. He was guessing that it was simple. If he knew what we know now, chances are very good that Darwin would not be a Darwinist. He would look at the evidence and go, my process can't explain this. Okay, so when we research, there's a tremendous amount of research trying to create life in the lab. That gives us a good understanding of what's required. So how do we make life in the lab? Really tough. We haven't done it yet. We've taken existing life and modified it and called it new life, but it's really not creating life. It's just tweaking simple life. There's a tremendous amount of research going on in what's called nanotechnology. It's making things at a molecular level, making nanomachines. And you hear all kinds of science fiction stuff about it, but it's true. People are making little nano robots, little nano cars, little nano medical treatments. So research in that and how you have to synthesize the chemistry required for life. We have very good understanding of what it takes to do that and what even the simplest life would require. And so making those chemical compounds, assembling them into nanomachines, which is really what life is well understood, and it hasn't made the problem of how we get to the first life any easier. It's made it more difficult. So the plausibility, this is a good summary, the plausibility of undirected natural processes and even the conditions in which those take place, the plausibility of all that happening by natural processes grows weaker the more we understand. So the trajectory right now is better understanding makes the problem worse. It's getting worse. Okay? And this is challenging for the broader scientific community, and that's hard to say categorically. Well, there's this group of people that are atheist scientists that are searching for the answer to the origin of life. But you typically will hear, like if you watch Nova or some science show or something, you'll hear terms like this all the time. We don't fully understand the origin of life. And the implication of that, I hear this all the time. In one form or another, what's being communicated is that we're this close to understanding it, but we're just not quite there. Like, we don't fully understand how the mind works, right? We don't understand the chemistry and physics of the brain that would explain how the mind works. But we're this close. We don't fully understand. The truth is is that in so many of these cases we have no clue. We really have no clue about how life began from non-life. We have no clue how the mind works relative to the brain. We have only the foggiest notions, none of which are plausible explanations, and the thing you'll hear me emphasize is that, and it's getting worse. Increased in understanding makes the problem worse. Now, who knows? Maybe there'll be a breakthrough. Somebody will come up with the, theory of the origin of life. But today, the case is that no explanation, and it's getting harder and harder to explain given our understanding. Okay, so that's a huge challenge. The origin of complex information in life, the instructions for life, how to build the parts, what to build, where to place them, how to replicate them, when to do this, are all contained in the instructions of life, only part of which is contained in the DNA. And the DNA is basically the software, the instruction set, and it's basically the instructions on how to build proteins, and proteins are the building blocks of everything that life is. It's all the hardware. So the DNA is the software, while the DNA contains the software. It's the holding thing for the software to build the things of life, which is the hardware. Okay, this information, these instruction set, carry complex specified information. In other words, it's like computer code. And the probability of that type of structure, that complex information arising from random mutations, is near zero. When you look at what it takes, it's kind of like you hear these analogies of take a whole pile of, those magnetic boards with magnetic letters that you can put on your fridge or whatever. Take 1 billion of those and throw them up randomly on a piece of metal and hope that they land just so they spell out the entire works of Shakespeare. I mean, it's those kind of things. I'm not saying that's an exact analogy, but to get the software, which is the instruction set for life to work, is somehow you've got to get all that information. I mean, at the end of the day, you got to have your operating system. You got to have Windows 10 or something like it, and that's all in the DNA. Where did that come from? It's just the probability of throwing these letters up, arranging these molecules just in the right way, even for the simplest life. The probability of that happening randomly, doesn't matter how much time and how many tries you take, assembling them all together, the chances are near zero that would ever happen. It just is totally implausible. And people recognize this, and it is a problem. So that's why generally they kind of ignore the problem and say, well, first you get the whole system, you get the operating. Now we can see how, okay, we'll tweak this algorithm, this, and maybe somehow we can get something new. But really the problem is pretty bad. How do you explain the information for this? The fossil record. Here we have the history of life, okay, recorded in fossils. And again, I'm taking a old Earth view, and I'm convinced that there's good reason for that. But we look at the fossil record, and we don't see any of the predictions of Darwinism. We don't see the foundational, slow, gradual change over time. What we see is, number one, everything's happening quickly. Quick origin of life. As soon as the Earth is capable of supporting Earth, or supporting life, boom, there is life. The Earth itself, its history, there's lots of evidence that, it came, through various processes, it came into being, part of the development of the solar system. For much of its early history, it was uninhabitable, it was way too hot, blah, blah, blah. It didn't have all those fine-tuning details required for life until a bunch of things happened, I believe, by design. But as soon as it was ready for life, boom, there was life. Darwinism, or chemical evolution, would predict that even after the conditions were ready for life, it would take untold eons before life would appear. But the fossil record shows opposite. We see a tremendous, rapid origin of all of the animal types. They're classified in terms of in terms of phyla. These are the basic body plans of all the different types of animals. So Darwinism would predict that would be a very slow, steady process over many, 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 many years, and we would see that in the fossil record. That's not what we see. What we see is there's no animals, no animals, no animals, no animals, and then all of a sudden in this event that you'll hear termed the Cambrian explosion, boom! It's literally an explosion of life form and variety. That happens in a geological instant. Okay, that's a challenge for us today, and it's a challenge for Darwin. In fact, one of the guys that I will cite is wrote a book called Darwin's Doubt, and this was precisely the thing that he struggled with all his life, because the Cambrian explosion represented in the fossil record does not fit his theory. The data doesn't fit the theory. When the data doesn't fit the theory, you can say get another theory. Okay. Instead, the fossil record suggests what scientists have tried to have given a name, but not an explanation. They call it punctuated equilibrium. Anyway, as I was saying, and I know I got to wrap up, so I'll be quick here. So, punctuated equilibrium is just the theory, the tweak on Darwinism to say that really what happens is that when the environment is stable, then there's really no reason for things to evolve. There's no evolutionary pressure. But then if the environment changes, then all of a sudden there's this tremendous pressure to adapt and to change. And that's when big portions of evolution take place. That's why we see these periodic spurts rather than this slow, steady thing. All of these examples involve rapid changes which are counter to the Darwinian explanation. Okay, so rather than trying to blaze through this very important topic of irreducible complexity, I'm going to pick that up next week. And it's really, it's a good concept to get in your toolbox and to be able to explain, because it really succinctly provides a big challenge to this idea of Darwinianism as a natural explanation. And then I'll talk about intelligent design. I'm going to leave you with some resources. The Discovery Institute up in Seattle, available at this website, is a great resource. They are behind a whole movement over the last 20 years called intelligent design. They're basically the proponents of this alternative theory that they call intelligent design. In their work, they've communicated that at a lay level, at a level that we can understand through Illustria Media. And if you go to their YouTube channel, and they made The Privileged Planet, which you watched. They also made one called Unlocking the Mystery of Life. And so I'm going to encourage you, although I won't require it for homework, to add that to your watch list. Unlocking the Mystery of Life. It will explain these things that I've talked about in terms of design in biology much better and with great, although older, graphics. And it will drive home especially the idea of irreducible complexity that I didn't get to today, but we will next week. Stephen Meyer is one of the lead ID people. He's written two very important books. One is called Signature in the Cell, one's called Darwin's Doubt. Michael Behe also is a key contributor to this movement of intelligent design. He wrote Darwin's Black Box, which talks about irreducible complexity. He wrote a follow-up called The Edge of Evolution, and he's just about to release another, the final of his trilogy about how Darwinian mechanisms actually tend to drive advanced life to extinction, not to better survivability. So for next week, read chapter 6. It's the moral law argument. It's how do we explain moral laws. And your homework is, again, your half page to 1 page. You guys are doing excellent on them. Answering these 3 questions. What's the difference between subjective and objective when it comes to morality? Those are key terms we need to know. Another term, distinction we'll need to make, and we'll cover this next week, but I want you to give a first stab at it. What's the difference between what we call objective morals and absolute morals? And then last, why is the existence of objective morals so important in the argument for God's existence? So answer those 3 questions. Okay? All right. We shall see you next week.
Thank you.
Thank you. And for you guys in Osaka, I will see you on Monday. Look forward to a lively conversation. Okay, bye-bye.